Since my last mood lamp video, I have been working on something new. I'm really excited about it. I listened to all of the suggestions left to me in the comment section, so I decided to put something together. Now, seeing as today the final season of Game of Thrones starts, I decided to pay tribute to it by including it in the project itself. Hello makers, I'm Joe, and today I'm going to show you how to make your own 3D printed revolving lithophane LED lamp. Stick around. It all starts off with obviously the 3D printed parts. Now for this project I use Protopasta Steel PLA. It prints really nicely at about 215 degrees, and since it has steel in it, it can later be sanded and buffed to get a bit of a shine. Plus it has a bit of weight to it as well, so it makes it feel much more solid. Next, we have the Lithophanes. Now, these can be 3D printed normally on an FDM printer. I had done a video a while back on how to go about that using a website called 3DP Rocks, but for this project, I used the Zortrax Inkspire, which I am currently reviewing. Now, when planning out the Lithophanes you are going to use, there are some ground rules which you have to follow in order for them to fit in the lamp frame that I designed. The photo must be in a specific size, and that is 1920 by 1080 pixels. You have to use the outer curve option in 3dp.rocks, and in the model settings you have to set your maximum size to 120 millimeters. Set the border of 3 millimeters, and last but not least, make sure that in the image settings you set the first option to positive image. Now, after I printed the main parts, I decided to sand down all the outer shell with 240 grit sandpaper until it smoothed itself out. Once I was done with that, I followed by 1000 grit wet and dry sandpaper to polish it out as much as I can and get as much of a sheen I can out of the steel within the filament itself. Once I was happy with the result that I got, I decided to spray a few coats of clear coat lacquer to get that gorgeous shiny finish and yet still expose the steel particles within the filament itself. Now, once you're done with all the 3D printed parts, you'll need the rest of the components. You'll need a strip of WS2812B addressable LEDs. You'll only need 1 meter of this with 60 LEDs in each meter, one 6004 bearing, a Wemos D1 Mini, a step-down converter. Now this can be excluded if you have a 5-volt power supply with enough amperage, stepper driver and the stepper motor, an on-off switch, DC jack, some male-to-male jumper cables, and finally some cable ties, M3x10 screws, and a few M3x5 screws. First, grab the Wemos Mini and solder the pins onto the tracks. Now, the longer pins should be pointing out from the side of the Wi-Fi module. If you are using the step-down converter, put some solder onto the input and output pads so they are set. Following that, put some solder on the DC jack terminals and solder a couple of wires to them. Now, unlike what I did, I would recommend you use black for anything ground related and red for anything plus 5 volts or positive power related in order not to get confused. In my case, I didn't have those colors available to me, so I used what I had. Next, put some solder onto the pads of the switch. Trim the wires representing the negative coming from the DC jack, and solder it onto one of the pads of the switch. Next, pass the DC jack and wires through the switch hole on the base and push the switch all the way in securely and insert the DC jack into the slot in the base. Now, if you are using the step-down converter, solder the remaining free wire coming from the switch to the negative in on the step-down converter, and then solder the positive wire coming from the DC jack directly onto the positive in of the step-down converter. Finish this off by using one of the M3x5 screws to secure the step-down board in place. We will now adjust the voltage output from the step-down board. Plug in your power supply and turn on the switch you just installed. Grab a multimeter, touch the probes with the appropriate positive and negative outlets, and start turning the screw on the step-down board anti-clockwise until the output is 5 volts. Now please note that it might take around 10 to 20 turns before you might see some movement in the voltage output. Next, grab the stepper driver and use one of the M3x5 screws to secure it into the base. Then take the stepper motor, insert the printed small gear, and use an M3x5 screw to secure it in place. Once done, place the motor in its position on the base and use an M3x10 screw to secure it on one side. Don't tighten the screw all the way just yet. Grab the wires from the stepper motor and clip the end into the stepper driver. Now grab the LED strip and place some solder onto the end contacts, making sure that you take note of the orientation as shown by an arrow printed on the LED strip. Grab any 3 wires, cut off the female connectors only on one side and trim them off. Solder them directly onto the LED strip. Grab the other end of the wire you just soldered from the LED strip and cut off the connections of the grounds and 5-volt input wires only. Leave the connector for the direction wire completely intact. Separate to that, grab 4 more wires, cut the connectors of all the wires only from one side. Join the trimmed ends of 2 of those wires to the ground coming from the LED strip, and join the remaining 2 trimmed wires to the 5-volt wire coming from the LED strip. Place some solder to hold them together in place. Now grab all the wires you just connected and one by one pass them through the hole into the 3D printed base cover as shown. Now solder both sets of wires to the positive output and negative output separately on the step-down converter if you are using one. If not, these would be connected directly to the wires coming from the switch and the DC jack. Once done, take a wire from the positive and the negative ends of the step-down converter which you just soldered and connect them respectively to the stepper board driver. Take 4 more female to female jumper cables and insert them in the last 4 available pins on the stepper driver. It is now time to program the Wemos Mini in order to test out our progress. Now the Wemos can only be programmed when all the wires are unplugged, which is why we are not soldering directly to the board, but instead using jumper cables. Connect a USB cable to the Wemos and into your PC and launch Arduino IDE. Then load the LED sketch that you will find in the video description. Now we have to make sure that we have all the libraries that we need to make the Wemos work with Arduino IDE. So go to File, Preferences, and in the Additional Boards Manager URLs, enter the link as shown. It will also be listed in the video description. Then go to Tool, Board, and click on the Board Manager. In the search bar, enter ESP8266 and download the library for the board. Now we need to go to the Sketch menu, click on Include Library, and then select Manage Libraries, as we need to install a few libraries, unless of course you already have these. First search for Adafruit NeoPixel and install the library. Then search for Blink library and install that as well. Search for ESP8266 and install that library. And finally, check if you have the SPI library installed. If not, install that as well. Now you should have all the libraries required for the sketch. To test, go to Tools, then Boards, and choose Node MCU 1.0. The upload speed should be no more than 115/200 and select your comport. Now compile the sketch to see if everything is fine. Once that is confirmed, you can go into the sketch and you'll notice that within the setup process you have a bunch of X's listed. This is where you input the token that Blink sends you for the projects, your SSID and also your Wi-Fi password respectively. So now it's time to set up the Blink app. You can download the app from Google Play or the App Store on iPhone, open it and create an account using your email and password. Once you logged in, press New Project, type in the project name and select the ESP8266 device and connection Wi-Fi. Press Create Project, and at this point you'll be sent an authentication token by email, which you can then enter in your sketch. Go back to the app, tap anywhere on the screen, and you will get a side menu with interaction widgets. Choose the ZRGBA, hold your finger on the widget to move and then resize. Tap again on the screen where there are dots and choose the slider widget. Once placed and resized, tap on the colored zebra widget to bring up the settings. Slide the output to merge and change the pin to virtual 2. Next, tap on the slider widget, set the pin to virtual and V0, and then change the output from 1023 to 10. And that sets up your app completely. Now we're going to go back to the sketch, copy the authentication token which you received in the email into the first set of axes on the sketch. Instead of the second set of axes, enter your SSID or the Wi-Fi device name in your home. And in the third set of axes, enter your Wi-Fi password. Now it's time to upload the sketch to the Wemos Mini. If you encounter any issues whatsoever uploading, try to unplug the Wemos and plug it in again and changing the speeds. Possibly also check your USB cable. So now that the code has been uploaded and the app has been set, it's time to connect all wires and test it out. Take the 4 wires coming out of the stepper driver and connect them to the Wemos. From the driver in 1, it should connect to pin D5, in 3 to D6, in 2 to D7, and in 4 to D8. Make sure they are in that exact order. Take the last 2 wires coming out from the step-down converter, positive and negative, and insert them into the pins marked 5V and G respectively, G being ground. Finally, take the last remaining wire you have coming from the LED strip and push it into the pin D2 on the Wemos. Now it's time to test. Plug in the power supply, switch on the lamp, open the Blink app, press play on the top right hand corner of the screen and it should connect automatically. Tapping on anywhere on the color spectrum should turn the LEDs on. Changing the position of the slider on the screen should also turn the stepper motor. The higher the slider goes, the faster it will turn. Once you confirm that everything works, take the LED strip, remove the tape cover on the back, and arrange the LED strip on the spiral around the tower of the base cover. There should be roughly about 4 turns, so just space them out as evenly as you can. Once you are happy with the position, you can just use some hot glue or tape to keep everything secured in place. Now the Wemos slides vertically into a slot in the base. Now seeing as it has no way to secure it with screws, placing a bit of hot glue at the base of the slot and pushing the Wemos in will hold it in place. You can now grab the zip ties and do some cable management as you don't want any of the wires to snag onto the gears of the lamp. Next, grab the bearing and slide it into the center of the base, followed by the gear tower, which should have a very snug fit as well. Make sure they rotate freely. Now push the stepper motor against the gear tower so that the gear teeth fit into each other and secure the stepper motor with another M3x10 screw, making sure you tighten the first screw that you had used. Grab the base cover with the light, turn it over the gear tower, and quickly test out the lamp once again to make sure it turns freely as it should. Finally, grab 4 M3x10 screws and secure the base cover in place. Now grab the lithophane top frame, slide the lithophanes into the slots one at a time very gently. Take the frame holder and secure it into place with 4 M3x10 screws. The very final step is to grab the lithophane frame, align the square notch at the center with the gear tower, plug in the power, switch it on, run the app, and enjoy. I really do hope you enjoy this project. It's been 4 weeks in the making now. There's been a lot of iterations. I think I did about 25 or 26 different iterations of this, always a work in progress. Now, a few things. The reason why I used 5 volts to power the stepper motor instead of directly from the 9 volts of the power supply I am using, even though the stepper motor can take up to 12 volts, is because it was running really hot on 9 volts and it was literally going to start melting the PLA inside the base. So I used the 5 volt output, and that reduced the temperatures by about 30 degrees. So that works fine for me. The fact that it turns very slowly, it just uses much more torque and it tends to heat up more. As for the code, it works. It's not flawless, but keep in mind, I'm still learning, so bear with me. I will be updating that code eventually, and it's open source, so everyone can, you know, download it, make your own lamp, use it, improve on it, and let me know so I can share it with everyone. One more thing, because I get a lot of people sort of commenting like you should have done this better. I know that I'm still learning, so once again, bear with me. What I'll do is always check out, before you start commenting, always check out the first comment in the thread below to make sure that I haven't done any updates. I will list any instructions over there. That is it for today, guys. I want to thank you very much for watching. I want to thank Protopasta for supplying the filament for this project. I want to thank Game of Thrones for bringing out their season 8. Yay! And I want to thank my absolutely awesome patrons for their support, with whom without I wouldn't be able to do this stuff. If you have any questions, leave them in the comment section below. Make sure you like, share, subscribe, ring the bell for notification, and as always, happy making, guys.